Good afternoon. I am Selva Simulation Engineer. I would like to extend a warm welcome to everyone for EGS webinar. We are delighted to have you here with us as your presence adds a great value to our meeting. I will start with the overview of who we are and what we do. We EGS India does engineering services, 3D CAD software, sellings and FEA service since 1993. We have implemented PDM PLM to many of our customers. We have three branches in which Chennai is our head office and sub branches in Coimbatore and Trichy. Solidworks is well-known software in market in which we are one of the leading resellers in Tamil Nadu. Our vision is to create a better engineering solutions by collaborating. Our mission is to give a better technical support which includes software solutions, new product development, and so on. And our legacy started from 1981 in US, and later on our MD Mr. R. Natarajan started out operations at 1993 in Chennai as engineering service for OEMs. And expanded for academics training at 1996 moving forward. As well as known, FEA software Cosmos has been represented by EGS India, which has later occurred by Dassault Systems, which is now Solidworks simulation, as many of our customers are using it. In 1999, EGS, we partnered with Dassault Systems as a technology partner for Solidworks in India. And then we have expanded our operations to support our customers at Coimbatore in 2007 and Trichy in 2009. And we have moved to our own building in 2011 at Kodambakkam as head office. And who we are. We are supporting the customers for past 3 decades. We have 140 plus associates to support our 1500 plus customers across India with consistent year-on-year growth. We are affiliated members of SAE India, IPA and other industrial categories. We have separate predefined teams for each and every process. As I mentioned earlier, we are one of the oldest partner of Dassault Systems for Solidworks in India, and this year we are stepping into 25th year in association with Dassault Systems. We are number one partner for technical support in India as rated by customers' feedback. The overview of Dassault Systems, 22,000 plus people are working passionately across globally with 69 R&D centers. In India, the R&D center is located in Pune. Solidworks has 3 million commercial customers with 25 million across 140 plus countries serving more than 12 industry verticals. Engineering services like new product design and development, design validations, value engineering, PDM PLM support and implementations. We have done it for customers like FL Smith, Flextronics globally. We also do software customization and automation using API. In software solutions, we provide SolidWorks simulations for manufacturing industries. 3D Sprints Works, which is the latest version of SolidWorks with basic PLM functionalities, where many of our customers are using. We provide logo press for customers who are into die design, sheet metal, nestings, and blanking. We also provide segment for tolerance stack-up analysis. Through our academics division, we provide a technical training on CAD, CAM, CAE for engineers to hone their skills. We also provide trainings on GD&T, FMEA, DFM, and DSA. Why EGS? We proven product design and development experience for customers worldwide. We also have proper documentation DFQ process to transform ideas into real-world products. We have a dedicated engineering team to address the critical business issues and product process developments, and establish the business process and organizational structures. Knowledge of APQP TS16949 process. Experience with automotive OEMs across passengers, commercial, off-road vehicle segments. And we will jump into the today's topic. Today I shall be guiding you through how this powerful simulations tool helps engineers and tool makers design better plastic parts and molds. We have participants from design, manufacturing, and tool room backgrounds. So today's content is tailored to show practical value across these roles. What is plastic injection molding? Plastic injection molding is a manufacturing process where molten plastics is injected into a mold cavity under high pressure, cooled and solidified into form precise, durable parts. It is widely used in automotive, medical, electronics, packaging, and consumer goods industries because it enables high volume protections with consistent quality and tight tolerance. It involves a various process in a mold design. A well-designed mold reduces the defects and shortens cycle time. Material preparation directly impacts the part quality and consistency. Uniform melting avoids the short and flow defects. Injection is where design meets the reality. Precision here defines the final part. Cooling efficient reduces the cycle time and improves the dimensional stability. An injection point of view, smooth injection ensures the productivity and reduces the scrap. Inspection and guarantees that simulations predictions match real world performance. What is Solidworks Plastic? Solidworks Plastic is a simulation software used to analyze and optimize the plastic injection molding process before manufacturing the mold and physical product. It works inside the Solidworks environment and helps the engineers to predict manufacturing defects, improve the mold design, and reduce the development cost and time. In Solidworks Plastics, including a built-in database of 4,000 thermoplastic grades supplied directly by global manufacturers. Properties are verified and updated regularly, ensuring the accuracy in simulations. A default database are read-only with manufacturing verified data, example SABIC, Viewpoint, and PowerStroke. User-defined database, engineers can copy, edit, or add new materials with custom properties for local suppliers or properties blends. Flow behaviors capture the viscosity curves, melt flow index, and thermal properties capture the conductivity, specific heat, and mechanical property capture the molds, shrinkage, warpage, and entities. Cooling fluid properties will capture the mold cooling and analysis. We have a dedicated meshing tool along with our Solidworks Plastics. The meshing is a process of dividing the geometry into small finite elements connected by nodes. These elements help the software numerically solve complex engineering problems. In Solidworks Plastics, we have a tetrahedral hybrid mesh, hexahedral mesh, automatic mesh, also mesh control options like surface mesh density, refinement methods, advanced controls. We will discuss on each and every mesh types. Tetrahedral hybrid mesh. Use the triangular surface mesh as a basis for creating a tetrahedral volume elements. Add boundary layers of prismatic elements near surface to capture the thin gap and flow behavior. Best for complex geometries and thin fissures where tetrahedral elements alone may distort. Hexahedral mesh employs non-orthogonal hexahedral elements aligned with melt flow directions. Provides more accurate and efficient solutions when aligned with cavity geometry. Automatic mesh fasten options with minimal user intervention. Automatically assign the mesh size based on the part dimensions. Use curvature based refine to capture the small features. This is the complete portfolio of Solidworks Plastics. Solidworks Plastic Standard is entry-level injection molding simulation package embedded in Solidworks CAD. It enables part designs to predict how molten plastics will flow into a mold cavity, helping them identify potential manufacturing defects such as well lines, air traps, and short shots early in the design stages. Solidworks Plastic Professional is the mid-tier package in a plastic shoot designed for tool makers and mold designers. It extends the capabilities of plastic standard by adding runner balancing, cooling analysis, and cycle time estimation, enabling engineers to optimize the mold layouts and improve the tool room productivity. Solidworks Plastic Premium is the highest tier package in Solidworks Shoot. It includes all capabilities of standard and professional, plus advanced workplace predictions and full integration of part, mold, and process analysis. In this live demonstration, I will showcase how Solidworks Plastics is effectively used by both plastic part designers and tool room engineers. We will explore its user-friendly interface and highlight the wide range of capabilities it offers, from predicting the flow behavior to optimize the mold performance, so you can see firsthand how it streamlines design and manufacturing workflow. Now we are opening the model in the Solidworks interface, where you can design the 3D geometry. For this demonstration, the model has been defined with the thickness of 0.6 mm. Next, we are adding the Solidworks Plastics into the Solidworks interface to simulate and run the analysis. The key advantage here is that both design and simulations are integrated within the same environment, meaning if any changes are required, you can quickly redesign and rerun the analysis without leaving the interface. In this step, we select the polymers material from the Solidworks Plastic Material Database. The software contains a large library of commercial plastics materials from different manufacturers. Here we can see the viscosity curve and other material properties. The viscosity graph shows how the molten plastics behaves at different shear stress and temperatures. Important material properties considered in the analysis include melt flow characteristics, thermal conductivity, specific heat, PVT behavior, shrinkage behavior. Select the correct material is extremely important because it directly affects filling time, injection pressure, cooling performance, and workplace prediction. Next, we define the gate or injection location. The gate location determines how molten plastics enter the cavity. In thin wall components, the gate placement is especially critical because flow resistance is higher due to the reduced thickness. And we are going to mesh the model, meshing device geometry into small finite element for numerical calculations. For thin wall studies, shell meshes are commonly used because they effectively capture the flow behavior across the thin sections. For injection location, I creating a local mesh or a fine mesh to capture the behavior. After the gate location settled and the meshing done, we will run the fill analysis. The software calculates how molten plastics flow through the cavity over the time. During the fill analysis, the solver evaluates the short behaviors, cooling time, running times. Solver shows the warning short, that is when the molten plastics is failed to completely fill the mold cavity during the injection. When the wall thickness is too small, molten plastics cools and solidifies quickly before the cavity is completely filled. Due to the short issue, we are revising the design of the injection port so that I change in the configuration from thin to thick. The thickness is being increased from 0.6 mm to 1.2 mm. As both interface operates in the same environment, so that design changes allows the analysis to be completed quickly and efficiently, significantly reducing the pre-processing time. We can run the simulations at the thickness of 1.2 mm by placing the injection location, remeshing the pot, and rerun the analysis. During the run, the analysis tab shows how the solution is converging. By rerunning the analysis, it will lively showcase how the molten plastics is filling into the cavity. It shows the real time how the plastics fills the cavity after the completion. The results allows us to check the pressure at end of fill, evaluate whether the pot is easy to fill or not, evaluate whether the filling time is exactly mapped by the analysis software, and examine the cooling behavior and easy to fill or not. We can then access the temperature at the end of cooling along with the potential shrink marks, air traps, and well lines. It will showcase how the behavior is happen when the plastic mold is injected into a cavity. Next, we will jump into the multi-cavity analysis. A multi-cavity plastic analysis in Solidworks is a powerful approach used to tool designers and mold makers to evaluate how molten plastics flows into the multiple cavities within a single mold. Instead of analyzing a single cavity, these methods simulate the filling, packing, cooling, and warpage behaviors across several cavities simultaneously. It helps engineers to optimize their runner balancing, gate placement, and cooling channels designed to ensure the uniform filling and consistent spot quality. We are now adding the plastic simulations to simulate the multi-cavity problem and creating a new study for this analysis. Next, a polymer material is selected from the Solidworks plastics material database. The material properties such as viscosity, melt temperature, shrinkage, and thermal conductivity directly influence the flow behavior and filling performance. These properties are editable and it can be done in Solidworks plastic interface itself. And next step, we are defining the runner and feeding systems. In domain, it shows two cavities. In domain, we have a hot and cold runners for this. I am selecting the cold runner. Here the runner and sprue geometry are generated. The runner system carries the molten plastic from injection nozzle into each cavity. The dimensions of the runner affects the flow resistance, pressure loss, filling time, cooling performance. By selecting the sketches on the runner or sketch, we can directly create the runner 3D model itself in the plastics interface. It is a major good point for us to exactly capture how the runner system will be created. Next step, the injection location or a gate position is defined. The gate acts as the entry point for molten plastic into a mold cavity. By defining the injection location runner systems, we are going to mesh the model. Now the model is meshed for the simulations. It divides the geometry into small finite elements that allows the software to calculate the flow and thermal behavior accurately. A finer mesh improves the accuracy, especially near the gate, thin sections, complex geometries. After defining the process, the parameters, the filling simulation is executed. The software calculates the flow front provisions, filling time, pressure distribution, temperature variations. It will show you lively how the plastic flow is injected in the cavity. In the post-processing results, we can see how much of time it's getted to filling the plastic mold, pressure at the end of fill. So what is the maximum cooling time is required to cool the hot molten plastic mold, and vectors, how the plastics flow is happen to the cavity. It will show us like in vectors plots, and if there is any well lines is created or not, we can exactly capture that also in a post processing process. we analyze the simulation results. The study helps to identify both cavities and filling uniformly, because there will be the two cavities are placed in a single domain, so that we need to check evenly that two domains are get filled at the same time as the same uniformly directions. And at the filling time consistency, well length locations also can be captured in the post processing, and the air traps is any defects are created in the plastics also we can get there. The major application advantages are in application size and injection mold design validations. Use the validate the mold designs before manufacturing by analyzing the filling patterns, pressure distributions, cooling behaviors, warpage predictions. This helps reduce the costly and mold rework and production issues. Multi-cavity mold analysis. Engineers use to balance the runner systems, ensure the uniform cavity filling, reduce the cycle time, improve the part consistency. It is very useful for high volume manufacturing industries. In automotive industries, it will apply for the simulations of dashboard components, clips and connectors, bumpers, insert plastic trims, air vents. Helps the automotive companies reduce the product weight and improve the manufacturability. Consumer product manufacturing is used in manufacturing of plastic containers, bottle caps, home appliances pots, toys, packaging products. It ensures better surface quality and reduces defects. A main thing in the medical device components used for syringe, plastic housing, medical enclosures. Precision mold components important for maintaining the dimensional accuracy and quality compliances. Electronics and electrical industries applied for switch covers, connectors housing, plastic casings, electrical enclosures, and helps to optimize the thin-walled plastic components molding. Optimization of cooling channels used to analyze the mold cooling efficiency, temperature uniformity, and cycle time reduction. Next. The main advantages will be reduced mold trial costs. A simulation predicts the defects before mold manufacturing, reducing the physical trial iterations. It benefits to save tooling cost, minimize the rework. Early detection of manufacturing defects can identify the air traps, well lines, sink modes, short warpage before production starts. Improve the product quality. Optimize the gate locations, runner design, fill balance, cooling systems, leading to better mold part quality. Shortens product development time. Engineers can validate the design virtually instead of waiting for physical prototypes. It results to faster design approval, faster product launch. Integrated with Solidworks. It directly integrates inside the Solidworks, allows easy geometry updates. CAD designers can easily update their designs to the plastic interface, faster workflow, simple design modifications, no need for separate CAD conversions. User-friendly interface. Easy for CAD designers, mold designers, manufacturing design engineers to learn and operate. Accurate flow and cooling predictions. Provides realistic analysis for melt flow, cooling time, injection pressure, clamp force, which improves process optimization. Helps to reduce the material waste. Optimize the runner and gate designers, reduce the excess material usage. Benefits to lower production cost, sustainable manufacturing. Solidworks Plastics helps the manufacturers to optimize the injection molding process, reduce the defects, lower production cost, and improve the product quality through virtual simulations before physical manufacturing. And thank you for all joining today's session. We hope this insight shared will support your journey with our solutions. For any further queries or clarifications, please feel free to reach out to the EGS marketing team. We will be glad to arrange one-to-one interactions to address your specific requirements. Thanks for joining. Once again, thank you.